3,000 years ago, Persian engineers cooled buildings to 60 degrees Fahrenheit in deserts that reached 120 degrees. They achieved this without compressors, without a single watt of electricity, and without monthly utility bills. The secret relies on a basic physical reaction. When hot, dry desert wind passes over a wet surface, the water evaporates. As it transitions, it absorbs massive amounts of heat from the air. This reaction was harnessed using elegant structures called wind catchers or bad gears. Built entirely from mud brick and ceramic, these precisely engineered towers captured the prevailing breeze and directed it over underground water channels, cooling the living spaces below. Many still operate continuously today. Today, most homeowners pay hundreds of dollars a month to run mechanical air conditioners, yet the physics of evaporative cooling remain exactly the same. By the end of this video, you will know how to build a passive system to cool your home for under $400. The shift away from free, passive cooling begins in 1902 with an engineer named Willis Carrier. He invented a machine to control indoor climates. Carrier's original intention wasn't human comfort. The machine was designed specifically to control humidity levels in a Brooklyn printing plant, so ink would dry evenly. By the 1920s, his company realized they could market this climate control to the general public. Movie theaters became the primary testing ground, acting as massive advertisements for mechanical cooling. This marked a deliberate shift in how we build. A passive wind catcher requires a significant upfront construction cost, but once built, it cools the structure forever for free. Mechanical air conditioning requires relatively cheap equipment up front, but it extracts a perpetual payment in the form of electricity, filter replacements, and compressor repairs. Following World War II, equipment manufacturers partnered heavily with electric utilities. Architectural schools dropped vernacular building science from their curricula, and building codes were rewritten to specify mechanical systems. The industry buried passive cooling because it did not generate a recurring revenue stream. To reclaim this independence, we are going to build a passive downdraft evaporative cooler. The goal is to force hot air to evaporate water, which causes the air to cool, become denser, and sink. This animation illustrates the process. As the hot, dry air pulls moisture off the wet pad, it drastically drops in temperature. Because cold air is heavier than hot air, gravity naturally pulls it straight down the shaft into your living space. No fans are required. Before buying any materials, you must test your local climate. Evaporation requires dry air. Use a cheap hydrometer or check the National Weather Service for your local summer humidity averages. If your summer humidity stays below 40%, you are in ideal territory for this build. Between 40 and 60%, the system will still function, but with reduced benefits. If your humidity sits above 60%, evaporative cooling will stall out entirely, and you should focus on thermal mass strategies instead. Working with the realities of your local climate, rather than trying to overpower it with electricity, is the first rule of energy independence. Start the build by constructing the exterior housing. You need a rectangular box that is 2 feet wide, 2 feet deep, and 4 feet tall. Use standard 2x4 lumber for the rigid framing and cover it with 3/4-inch exterior plywood. Next, cut an 18-inch square opening in the very top of the box. Install a rain cap over this hole to keep out weather, but ensure you leave exactly a 6-inch gap between the cap and the box. This gap is where your hot air enters. On one side of the box, down near the bottom base, cut a second 18-inch square opening. This serves as the exhaust where the cooled air will eventually drop into your home. Once framed and cut, take exterior caulk and run a thick bead along every single interior and exterior joint. This step is mandatory. The entire system relies on a natural downdraft vacuum. If air leaks through the cracks of your plywood housing, the pressure drops and the physical cooling effect fails. Inside the box, you need a highly porous material that holds water well. You can purchase rigid cellulose evaporative pads from HVAC suppliers, or use simple DIY materials like tightly stacked burlap sacks or coconut core matting. Mount these pads vertically inside the center of your plywood box. As you mount them, you must leave a 2-inch gap between the edges of the pads and the interior walls of the box. This clearance prevents the air from getting choked off, allowing it to flow effectively around and through the material. The entire cooling mechanism depends on exposing as much wet surface area as possible to the incoming hot wind. The greater the surface area, the faster the evaporation, and the steeper the temperature drop. To keep that medium continuously wet, run a 1/2-inch PVC pipe directly across the top of your vertical pads. Drill 1/8-inch holes every 2 inches along the pipe, so water drips evenly downward. Below the pads, secure a galvanized sheet metal pan with a slight slope. Connect a drain fitting to the lowest corner, routing the runoff down into a covered 5-gallon bucket. Inside that bucket, place a small submersible pond pump rated for about 100 gallons per hour. You can find these at any garden center for about $20. Connect flexible tubing from the pump up to your top PVC pipe and plug the pump into an outdoor timer. Set the timer to run for just 15 minutes every hour during the hottest part of the day. This closed recirculation loop is the only part of the system that uses electricity. Because you are only moving a few gallons of water instead of compressing refrigerant gas, the operating cost drops to literal pennies. Mount your completed box on a roof or exterior wall facing the prevailing wind. Connect the bottom 18-inch opening through the wall using insulated ducting and terminate it at a standard register inside your living space. This brings us to the exact point where most DIY builders fail. You cannot push heavy, cool air into a house if the stale air has nowhere to go. This diagram shows the solution. You must open a window or install a ceiling exhaust vent on the direct opposite side of the house from your cooler. This allows the heavy blue air to drop in, actively pushing the stale orange air out the other side. If that exhaust window is sealed shut, the interior of the house becomes a high-pressure wall. The dense, cool air inside the duct hits that pressure and simply stops flowing. Passive cooling requires a building to breathe. It is a direct rejection of modern architectural trends that design homes as hermetically sealed plastic boxes. When constructed and sealed properly, the results are immediate. As scorching 110-degree air hits the wet intake pads at the top of the unit, gravity pulls a steady column of 80-degree air directly into your home. It performs this continuous drop in temperature, even in the punishing desert heat, entirely through the laws of thermodynamics. The financial difference is stark. A standard central air conditioning system costs thousands to install and runs up immense hourly electricity bills all summer. This chart compares the exact breakdown. A modern mechanical AC requires roughly $15,000 upfront and costs 30 to 50 cents per hour to run. The passive downdraft cooler costs about $300 in hardware store materials and operates for 3 to 5 cents an hour. By completing this build, you bypass a century-old extractive business model. You replace a perpetual subscription with reliable physics. To keep the unit running efficiently, check your 5-gallon water reservoir once a month, drain it completely, and scrub the interior to prevent algae growth and stop mosquitoes from breeding. Every few weeks, inspect your evaporative pads. Hard water will eventually leave mineral deposits behind. If the pad feels calcified or clogged, pull it out and rinse it thoroughly with a hose. If you want to uncover more lost building techniques, hit subscribe. Then click the video on your screen right now to learn how burying underground thermal mass tubes can pre-cool the air before it even reaches your house. The industry buried this knowledge because self-cooling buildings do not generate monthly revenue. Now you have the blueprints to build your own.